Okay, today we're going to learn how to interpret computer regression output, which you're going to definitely have to do frequently. So we have an example here. When Mentos are dropped into a newly opened bottle of Diet Coke, carbon dioxide is released from the Diet Coke very rapidly, causing the Diet Coke to be expelled from the bottle. Will more Diet Coke be expelled when there is a larger number of Mentos dropped in a bottle? So we have a linear regression here. First we have our scatter plot, and then we have the least squares regression line overlaid, and then we have a residual plot. So we're going to be interpreting these. So what is the equation of the least squares regression line? Define any variables you use. So x is going to be your explanatory variable, which is number of Mentos. And then y is your response variable, and it's the amount of diet soda expelled and it's in cups. So you want to give your units there. And then the equation, you need to understand where to get that. So this is the typical look of a regression output. And what you have here, you see where it says Mentos. So Mentos, the coefficient will be your slope. So this will be your slope. To me, that's always the easiest thing to remember. And then the constant is actually your y-intercept, which is this value right there. So we will write this as y hat is equal to a, which is 1.00208, plus b, which is 0.07083x. So make sure you can read this. 0.0. Okay, so that is a relationship. So we need to interpret the slope and interpret the slope of the least squares regression line here. One thing I want to show you or point out here is that when you have a situation like this where you basically have discrete data, in that your x's are all whole numbers, 2, 3, 4, 5, because you're inputting the Mentos into the Diet Coke. So you can't have values in between. So what you're going to be looking for here is an overall pattern. So look for overall pattern. And you do see an upward, so a positive, and you do see that the line fits pretty nicely through the data there. Now, if you look at the residual plot, do you notice that the residuals are also sort of in vertical lines? So the residuals line up vertically by number of Mentos. And some of you, when you did your Are You Normal project, had the same type of result. If you did things like number of siblings, number of letters in a name, etc., you would have had the same type of situation. Okay, so to interpret the slope is 0.07083. And this is the way we're going to interpret this every single time. For each additional Mentos, put into the bottle, the amount of Mentos expelled, it's actually the amount of diet soda expelled. It's kind of a combination because the Mentos will start to dissolve, so it's actually a combination of diet soda with the Mentos in it. Expelled in cups, increases by 0.07083, and we already said in cups. And it really should be the predicted amount, because this is what's impacting the prediction. All right, so that is how you would interpret the slope for this situation. And don't forget, you definitely need to remember where you get your output from. Now, another thing we need to look at is the S. This is your standard deviation of your residuals. And then your R square, which is in percent form here, of course, but that's really important. We don't use R square adjusted ever. We actually don't ever use this information, the top row regarding the y-intercept. It's just not in the context of AP Stats. We will come back to this later, but for now, we don't use this either. Okay, so those, that information there. Okay, so let's go on and interpret the correlation and find the correlation first. We have to do that. So what I have here is I do know my R-square, so I'm going to use that to find my correlation. So the correlation R is going to be the square root of 0.602, and notice I converted this to decimal, and that is going to give me 0.7759. Okay, it's positive. Okay, and it is positive, obviously, but if I had had a negative slope, I'd have to put a negative out front. But this will be positive because the association is positive. So it's just like you have a positive slope for your line. So slope is also positive. All right, so always your R will either be positive or negative based on whether you have an association that's positive or negative, and then also the slope will be the same sign as R as well, but they are not the same thing. We talked about that yesterday. Okay, is a linear model appropriate for this data? And I would say somewhat. It's not terribly strong, but somewhat. Let me tell you why. The scatter plot shows a somewhat strong, positive, linear relationship. So I need to make sure I get all of my dots in there with no outliers. So let me kind of underline where the dots is. So shows a somewhat strong, positive, linear, and then I mentioned my outliers there as well. Okay, however, the R-square is only 60.2%. So however, the R-squared equal to 0.602 basically means that roughly 60% of the variation in Y is explained by this model. That means 40% of the variation in Y is not explained by this model. So that's important to know. So which means approximately 60% of the variation in, and I'm going to have to use some of the space over here, in the amount expelled is explained by the number of Mentos. Okay, the other thing you'd also want to comment on is the fact that the residual plot is fairly random about the line equals 0. So that's the final thing. The residual plot is fairly random. Okay, and I'm running out of space here, but I'll put about y equals 0. So your residual equals 0. All right, so that's how you're going to interpret that. Would you be willing to use the linear model to predict the amount of Diet Coke expelled when 10 Mentos are used? So the answer to that is going to be no. If you're asked to do it, though, you would do it with caution. So I'll say no, because the given data ranges from 2 to 5 Mentos. And predicting the amount of soda expelled for 10 Mentos would be called extrapolation. The extrapolation. Okay, the prediction would be unreliable. Okay, extrapolation is very important, and you want to use that in your writing. You want to always say what extrapolation is. You would definitely be asked that question on a test and also on the AP exam. It's a pretty important concept in AP Stat, so make sure you understand that. Okay, so let's move on to the next page. It says calculate and interpret the residual for the bottle of Diet Coke that has 2 Mentos and loss 1.25. So the first thing I need to do is I need to use my model to calculate the actual value for 2 Mentos from the actual least squares regression line. So here it is. Y hat is 1.00208 plus 0.07083, and I'm going to put 2 in here, and that's going to give me 1.14374. So that's my prediction. And so the residual here is going to be the observed, which is 1.25, minus the predicted 1.14374, and that's going to give us 0.10625. And that is going to be in cups, because you're predicting the amount of soda expelled in cups. Okay, so now we're supposed to interpret it as well. So that is when you say this is a positive residual, meaning that the model underestimated the amount that would be expelled. So the least squares regression line underestimated the amount expelled. All right, so one final question. If the amount expelled was measured in ounces instead of cups, how would the values of R squared and S be affected? So R squared has no unit, so not at all. R squared would not be affected because it has no units. R squared has no units. However, S does have units. So S has the same units as your Y variable. So it would be in cups here. So we have to think about converting from cups to ounces. And you know 1 cup is equal to 8 ounces. So every observation, every Y would actually be converted by multiplying by 8. So a new variable, I'll call it Y here, is basically going to be 8 times your old variable. So I'm going to have to do the same thing with regard to the standard deviation. So the standard deviation of the residuals is just going to be, and it's the absolute value of 8 times the standard deviation of our original variable. So this is going to be our original standard deviation, which we had on the other page. So it's going to be S would be multiplied by 8. So 8 times, and it's going to be 0.06724442.